Hello, and welcome to the Modeling an Electric Vehicle demo. This was created by myself as part of an independent study project at my school. So what this project does is it works to model the numbers of an electric vehicle. And when I say numbers, I mean the transfer of energy from one part of the car to another that actually makes it move forward. As we can see on the file tree to the left here, I created multiple different classes that each represent a different part of the electric vehicle. Then I created a specific vehicle, a Ford Explorer 2002, and created each of these objects with the actual numbers that correlate to that vehicle. The most difficult of these numbers to acquire is the automatic transmission numbers, which require the most in-depth knowledge of how the transmission actually works to be able to model it effectively. So what I did was I created the object classes here, and then a user interface for actually using the app. So we're going to go ahead and run the driver. And this is all written in Java code inside of the IntelliJ IDE, which is what you just saw. So as of right now, only the Ford option is actually enabled. Ford Explorer 2002. So we can start the simulation, which shows that the brake is held down, the key is inserted into the vehicle, and we can either play all the steps at once or we can walk through it step by step. So for an electric vehicle to work, the contactor has to be opened, which allows electricity to flow. The main batteries output about 25 amps to the motor controller. The motor controller outputs these amps to the motor, and some of these amps go into a secondary 12-volt battery. The motor converts the amps to horsepower and stores that in the flywheel. The flywheel spins and transfers this energy to the transmission. When the brake is released, this allows the transmission to use this horsepower and torque to calculate the engine rotations per minute, which in this case would be 20. So this is when the more complicated numbers come into range. It depends on the gear ratio, the axis ratio, and the RPMs, which you'll get from depending on which number of the transmission you're in, if you're using automatic transmission, which this vehicle is, and the vehicle is moving at 6 miles per hour. Then I show an example of what happens if you press down on the gas pedal. Well, this is going to up the number of amps sent to the motor controller, which is then going to do the same thing again that we saw before, but this time with just more amps. These amps get converted to horsepower. Horsepower gets combined with torque to calculate rotations, which is then used to speed up the car up to 90 miles per hour. And that's the end of the simulation for now. So the use for this project is just being able to track the energy movement throughout an electric vehicle. This could be used for safety testing or to determine if you have all the correct parts in the right car before you put it all together. Hopefully you learned something new from this. If you'd like to see more of what's happening in the Java code behind the scenes, please check out my GitHub linked on the YouTube account. Thank you so much for listening.